Cool. Recording is on. So, good evening, good afternoon, good morning from where you're joining today. Thank you for joining the 13th edition of London Network Automation Meetup, which is also the second virtual event that we're hosting. In this meetup, we have changed the structure 1 hour, and we'll see how we can stick to that. This means that the event and at the end of the sessions, we're going to stick to the traditional questions and answers and just a free session, to talk about various things. We have already received a few questions, and we've already started to talk about an interesting topic at the beginning, but we're going to wait until the end after the presentations. After each presentation, you will have maybe 2, 3, 4 minutes to ask any questions you may have about that specific presentation, if something was not clear or if you wanted some clarification. But also there will be some time at the end if you didn't get a chance to ask some questions after each presentation, but also if you have any generic question about network automation in general, you can ask the question at the end. The first presentation today will be held by Eric Chou, and the topic will be Python 3 and some of its new features which can be useful when used for network automation, but not only for network automation. Some of you may already know Eric, but Eric is a seasoned technologist with over 20 years of experience. He has worked on some of the networks in the industry, and he's worked at Amazon, Azure, and other Fortune 500 companies. And Eric is passionate about network automation, Python, and he is also the author of a number of books in this area. Eric, if I haven't covered anything, I'll let you introduce yourself in a second. But yeah, you're gonna go with the first presentation. So the stage is yours. Make your presenter now.
Awesome. Hey, thanks. So let me go ahead and share my screen and make sure it pops up and make sure I share the right screen. Actually. So if anything, let me know. Working? Okay, great. So so thanks. Okay, great. So thank you, Paul. Thank you, Matthias, and the whole London Network Automation Meetup group for having me. It's really good to be here. And as Paul was saying, my name is Eric Chou. For me, I've been working in the networking industry for about 20 years, and it's always just network engineering. I think it divides pretty well into like half and half. Let me go ahead and start my timer so I don't jip Anton for his time. But yeah, so I've been working and it's about half and half. So the first 10 years is really just operation focused, and definitely Cisco coming up with going the Cisco route with certification, and then I start working for kind of public cloud providers. So that's where I want to put a kind of a context into that. So that's where my automation kind of experience has been. So it's really highly skewed toward public cloud providers. So that sometimes is a bubble. So I do realize that. So whenever somebody wants to point out like, that doesn't work in the enterprise, I'm all for it. Just let me know when that kind of, that kind of situation arises. And if you're interested in some of the courses or books I've written, of course, here's the link for that. And I also put all the Jupyter Notebook in the GitHub repository. Feel free to check that out. Here's my Twitter link, here's my LinkedIn link, and feel free to connect and share knowledge. I love to geek out on a lot of these technology stuff. So in case you haven't noticed, or if you live under a cave for the last 10 years, we know Python 2 is dead. So it has been dead for about a year, over a year now, a year and a half now. So definitely, there used to be the question of which Python version, why do you use Python 3 instead of 2? But now there's no longer the question, right? Like Python 3 is here. We should start calling Python 2 as legacy Python. And if somebody, management wise, supposed to say, hey, we got to use Python 2, so and so, then you just have to say, hey, Python 2 is no longer supported, it's legacy, and you don't want to be the person responsible for a security breach the next time something happens, right? So Python 3 is here, and for the most part, I think for me, Python 2 to 3 transition, the code kind of just works. And especially if toward the end of your Python 2 journey, you use something like, from future import print, then you just have to change your interpreter, right? And so for the most part, it works. However, if you're just using Python 3 the same way you used Python 2 before, actually not taking advantage of Python 3's features, right? Because there's a lot of goodies out there that I want to point out, and for some of the things that it's certainly more than what we'll cover here, but some of the ones that my favorites are the F string and the type hinting annotation, and of course async IO that everybody's really excited about. And so today, that's the three things I want to discuss in brief overview. And the main theme for me, and this is true in all the things I've studied, all the code I've written, is really optimized for engineer productivity. So that is my overhanging, kind of a mantra for me. So all the features here, they're my favorite because they help me to become more productive. And hopefully I'll convey why in a bit. But that is the overarching theme, because and that becomes the answer for some of the questions I would get. Like somebody would say, what kind of IDE do you use? VS Code, is VS Code better than PyCharm or something like that? And my answer is always just, whatever makes you more productive. So I just want to keep that in mind, especially for some of these stuff that it doesn't impact the feature. It doesn't impact the functionality of your code. What it does is it makes it more readable, makes it more maintainable. And that is why they're my favorite. That increases your engineer productivity. So the first thing we're going to talk about is F strings. So, of course, these are existing ways that we could, manipulate strings within Python. So of course we have this, just concatenation. We could just kind of use the plus sign to group all the strings together, and that works, but it really doesn't work well. I mean, especially if you have a more complex string, or if you want to do any manipulation, you got to do it beforehand, and it's not very readable. And of course, we have this percentage format, and what it does is it basically substitute in place of the variables back into the string. So in this case, we could see what the string looks like, and we position them in at the end to make sure that they get substituted during runtime. Then, of course, using the same format, we could do some manipulation. So in a sense, this is a string, this is a digit, and because it is a float, then we could just say, hey, use 2 digits after decimal points. So that becomes your final output. So that works, but now we take one step further. And so far, we haven't gone into Python F strings, right? So these are just a different string format. And the difference is that for all the variables, now you use the curly brackets to represent them. And this does exactly the same thing, exactly the same way as the percentage notation as before. But now what we could do is, we could reference them by position, right? So this is 0, this is 1. So even though we have the same order of variables, but now we could put, the later part to the front, or something like that. And also, say that we have a dictionary with key value pair, then we could actually name this variable, and then we could substitute this variable directly inside the dot format. And that becomes much more readable. So now you're kind of knowing what this is about, like the string itself, and then you just go out and grab that variable. However, it's not as readable, or it's not as easy to understand as before, especially with the string that when it gets long. So in this case, this just gets longer and longer. Like for dictionary wise, you name one, name two, name three. And of course, I deliberately swap out like the order of these just to illustrate that we could do that. And there's some tricks to it. Like for example, you could unpack that whole dictionary within that format, and but you do have to use the same key as your dictionary. So this would give you the same thing, but just a slightly different, compact ways. So, and this one just to show that within the dot format, we could still use a flow manipulation where we say, hey, just 2 digits after the decimal point. So starting from 3.6, it seems like F string has been in Python forever, but when I did my research, it actually shows up as new in 3.6. So that's kind of cool. So what F string does is we can actually put an F, capital F or lowercase f, in front of our string, and now we could substitute in place for our string. So for example, in this case, we substitute those variables, and we could do simple expressions. This is kind of similar to what JavaScript could do, that they do simple expressions within in place. So we could do that, and also we could call the method directly, right? So fr1 is a string, and now it has upper, and we could call it directly, and that makes it more compact and readable. Of course, we could use our own functions. So in this case, it does exactly the same thing as what we've done before, but notice this is our own function that we're calling here. And of course, we could do multi-line F strings, and this is very helpful in terms of like if you have a template that you need to just keep in place of a lot of stuff, but you still want it to be more readable. So I think F string is one of these things that you could plug in directly to your code if you have used the old way before. One kind of factor your code to make it more readable, better, and it's really one of the coolest things for Python 3. So let's talk about type hinting. Yeah, sorry that I just want to make sure I keep a track of time. So of course, type hinting started out in 3.5, and the benefit is really make your code more readable. And you do need more work when you're writing, and keep in mind the type hinting, but it's a trade-off between extra work and also readability of your code, and makes it more maintainable. And with more comments and type hinting and annotation, it also helps the IDE to catch your error, because they actually leverage those, especially the more modern ones. I mean, not like Sublime tags. I don't think those do that without plugin, but for PyCharm and Visual Studio Code, they actually do that natively if you put the type hinting in there. So this is it's kind of a comparison between like static typing, as we know. So for some of the static type languages like Java, you have to declare that this variable is a string, and now I plug in the value to it. But for Python, it's dynamically typed. So we just declare a variable, we put in a string, and during runtime, the interpreter would do a best guess that this would be a string. And for the most part, it works fairly well. So what does type hinting help you do? So if you look at this toy function, that this doesn't have any type hinting, and this is the way that we've done it before. And of course, the name argument that we're passing in has to be a string, because we're actually calling upper, and that only exists in string. But there's nowhere here that it will tell you that this name variable has to be a string, right? Especially if this kind of an imported function, if you import this function from somewhere else, or if you have like a long program that you thousands, right? Like at the 1,000th line, you already forgot what you saw at the very top. So that becomes a little bit of confusing, right? So in this case, if we just pass in a string, everything works as expected. But if you're passing a integer, then now becomes more apparent that this wouldn't work. So wouldn't it be great that we have this before we actually run into an error? So in this case, the type hinting, really is to hinting in your argument. So in this case, we could see, hey, the name should be a string, and whatever we return. So we have this arrow where we know that the return value will be a string as well. So that's great. Readability wise, when we call this function, especially in your IDE, if you scroll down or whatnot, then you would hint you. But is this actually enforced? So it turns out that it's not, right? So it's even though so it goes back into the fact that Python is dynamically typed and it always will be. That it's a nice to have and it helps you to do this better. However, it's not enforced, right? So you could still do that. But what we could do is we have third-party programs like such as MyPy that you could install this MyPy, and let's just say we have another Python program here, which is the same example as we have before, and we're making the same mistake of using it and calling an integer. But we could run it through MyPy, and it will go ahead and tell you that is incompatible. And now before we run the program and run into the error, that we have this checking for us, right? Another safety net for us to better code. So you're saying this is so simple. Why am I typing more characters for such minimal amount of gain? True. If you're having simple programs like that, you don't need to. I don't encourage you to. But if you have something just a little bit more complicated, then there's more typing that you could import. For example, you could import iterables. So the argument that you're passing in should be something like a list or dictionary, or even a string that's more iterable, right? So then you could pass in that iterable to indicate that this should be either a list, dictionary, or something iterable. And you could also importing optional, right? So the optional would tell you that this argument is actually optional, but if you do pass it in, this should be string, integer, iterable, or something like that. So here's a example of how IDE would catch it. So this is without any of the type hinting, and now we have this function where the device should be something, right? But you don't really know. So when you call this function, there's not that much help from the IDE. You just kind of you're back to reading the documentation. Hopefully there's documentation, right? But with type hinting, that would say, hey, the device should be an iterable. It's a switch object. It return an integer. And now when you in your IDE, it's actually tell you this is a device and should be an iterable and a switch object, and you return a integer. So in this case, I'm actually using the simple ones to put in this name tuple to say, hey, this is an N3K switch. I have 20 interfaces, and so then I would aggregate them and combine them and know how much total interface do I have in my spine rows or leaf row or something like that. So that's cool. And this is actually one of those items that would really help you as well. And if you want more information, here are 2 additional links. And I would highly recommend this library called Pydantic that you want to. If you want to use MyPy to run through every single one of your Python program, welcome to do that. But this Pydantic library will actually allow you to check within the program, and you can actually define classes with type hinting and type annotation, and it will actually check on the spot for you within your IDE. So highly recommend that. And for some of the newer libraries and frameworks like Fast API, they take heavily use of Pydantic, and it actually enforces the checking. So for example, we actually, when we're passing values on the internet, even though this is an integer, even though this is like a float or whatnot, we still pass them as strings, right? So now you're passing them, it's a JSON object, it's a string, but it's passing it's an integer, but it's passing in string. Now I have to convert it back and so on. So imagine if you have to do that checking manually versus if you could just define a Pydantic class or object, and then you're enforcing that, then you'll return. So what Fast API would do is it take those hints and it will return those error directly to your client and say, oh wait, hold on just a minute, you gave me a integer, but this should you gave me a string, but this should be integer or anything like that. So highly recommend this library. So then let's talk about async IO. And to be honest, I'm not. I mean, this is actually something I'm actively learning about and really trying to get better at. But I'm still kind of testing it out. So Anton would do a much better job in explaining this, but I'll do my best, right? So async IO is really aimed at increase the performance of your code, and this is trying to tackle the issue of running multiple tasks at the same time using the async await syntax. And the caution I want to give people is that async IO, at least for me, is not very easy. And I love this quote. It says, "Premature optimization is the root of all evils." And I think that what the quote means is that you should always try to make your code work. So if you try to make it work and not think about any kind of optimization until it works. So that's kind of the lesson that I take to myself. So usually you want to make sure your code works, everything is working as expected before you try to optimize it. In this case, I would classify async IO as a optimization method. So after it works, if you're trying to make it faster, go ahead and do that. Another caution I want to point out is that async IO module for Python is under it has been rapidly developed. It's available, I think, as a beta since 3.5, I want to say. And during the time, it's between 3.5 to 3.7, it has changed the syntax a little bit. So sometimes you will see examples out there that still reference the old way. But if you're using async IO, I would highly recommend just starting out with 3.7. So why do we need async IO? And it's as said before, is trying to eliminate the performance bottleneck. So when you have a program that does stuff and it seems to be really slow in completing your task, it could be one or two ways, main ways anyway. So one is CPU bound, whereas maybe it's doing a lot of compute intensive mathematical programs, or it could be IO bound, where it's waiting on something, like you're writing or reading a file on the disk, or for a lot of us, we're waiting on API calls to return back, right? We're calling the device API call and the device's API, and we're trying to return something. And during the time, Python is just there twiddling the thumb and say, oh, what's going on? What's going on? Nothing. And I'm just blocked, right? So Python's solution for CPU bound tasks is multiprocessing module. And we're not going to go into that because it's outside the scope of this presentation. But Python's previously answer to IO bound tasks is really the threading and the queuing module, where it's starting out the queue. Like before you start your program, you're saying this is what you're going to do. So you start multiple threads, and then you start passing in tasks to each of these threads, and then they're working concurrently. You're putting into a queue, and then you collect them at the end, and then do whatever you need to do with them. So this is called the previous using the threads called preemptive multiprocessing, where it's before you start doing them. And because of Python, a lot of us know Python have this global interpreter lock that it has this complex relationship with threading. So it actually passes down to the operating system, I believe, so that it passes it down. So therefore, once you give that control over to the operating system, then you have no visibility within each of these pipelines, how they're working together, right? So there's always the chance that one task, completed before the other, or if there's dependencies between these two tasks, then you have no way of stopping it in midway and cooperate between them. So what async IO does is actually does this via cooperative multiprocessing, where you still have a single thread, single CPU, but these tasks are working side with each other. So how does that really work? Because it's counterintuitive, right? Like it doesn't really make sense that you have one single CPU, single thread, but you're able to do multiple tasks at the same time. So the best analogy is, that I saw was from Real Python, and they actually referenced to Miguel Greenberg's 2017 PyCon talk. So basically, it's saying that let's just assume you have a chess master, and it's playing multiple components at the same time. And what this does is the chess master is able to make a decision really, really fast, like 5 seconds. And each of the components would take 55 seconds to make a move. So what happens if the chess master have to do it sequentially? And while that opponent is making a decision, you have to wait. And before, then you have to wait till the return the move, then you do it again and sequentially. So that would actually take a really long time, right? But what if what we could do is while I'm waiting, while the chess master is waiting, that you releases that task to me and I move on to the next person. And so therefore I could just do it really, really fast and cut that down from something like 12 hours to 1 hour, right? So that is kind of the analogy that they have about how async IO works, even with just a single CPU and a single thread. So typically the steps to do async IO is you have to make your function to be a coroutine using the async keyword. And within the async coroutine, you have to have some sort of task that awaits you, that they could release the control back to the interpreter, so they could move on to the next task and then so on and come back to it when something else is completed. And you want the third step is really to group these coroutines even into a bunch of tasks that you work on together. Remember, it's cooperative. And then you start your event loop and then start executing them and say, these is the bunch of tasks I want to do, and you go ahead and give me the result when they're completed. So here's the synchronized and also these, in order to execute the following programs that we need to install AIO HTTP as well as request. And the request is AIO HTTP is a async, a waitable, equivalent of request, basically. So here's the first example of, just doing something that's sequentially. I am doing it 3 times, just counting and sleep in each one. So 1, 2, 1, 2, 1, 2, and that is executed in 3 seconds. Oh, I'm sorry. So due to the limitation of Jupyter Notebook, because Jupyter Notebook, I was already started an event loop. So we actually have to execute this program outside of Jupyter Notebook, which I have right here. So what is this? I think async time. Yeah. Okay. So if you see this, this is a async coroutine. It's awaiting this task, and now we're gathering these tasks together with gather, and then we start the event loop and we execute them. And here's the output that you saw on my screen, where it just execute at the same time, and it cuts down to quite substantially into 1/3 of the time, because they could use it concurrently. So the next example is a little bit more relevant to us. Basically, what I have is I have a program that uses Fast API, and what it does is has an endpoint that you could specify IP with IP with the IP address, and then use the version to get the version. So in this case, if I just execute it, then I get 192.168.2.60's version, right? And so this is just a raw output, just in case you're executing and you don't want to execute it separately. So this is this is a synchronous version, and just to kind of expand the results, I only have 6 devices, but I'm running them twice, so therefore I'm executing it 12 times. And if I just execute them, and it's doing session 1, session 2 is getting the responses, and if I come back to my Fast API program, I could see like these are just 200 OK that's returning, right? So at the end, 9, 10, 11, 12, and at the end, I'll see that this program is executed within 22 seconds, right? And now if I make that program async IO with AIO HTTP and doing the same thing, then let's do that. async show version, I think. Yeah, so now it's executing it. And I also want to kind of point it out that I've actually deliberately sleep 1 second. So this is going to at least take 12 seconds, right? Because I deliberately sleep only because my, not the fast API limitation, this was a limitation on the underlying library I'm using, which is NetMiko. So I'm actually using NetMiko and it's not async. So if I just blast it too fast, then it would, not happy about it. And I don't know if you guys saw that, but it's executing it first because I'm gathering all the tasks at the same time. And I'm saying only return the control back to me when everything's complete. So compared to the result before where we secretly get the result, we're only getting the result back at the time, and the end was 14 seconds. Remember, I'm deliberately waiting 1 second, but it already reduces the time of execution by 50%, so 100% faster. And I would definitely recommend Carl, and also I'll modify it for Anton's library that he'll present in a bit about because this is hard and you don't really want to deal with it unless you have to. If you could leverage some of these libraries that others have already done and increase the performance, definitely encourage you to do that. And we don't really have time, but these are some of the interesting Python 3 libraries that I found that are new in Python 3. And if you're interested, go ahead and check them out. So I know I'm kind of 3 minutes over, so sorry about that. But let me go ahead and stop sharing and pass the control back. Thanks again.
Thank you, Eric. And yeah, don't worry. I think I probably just eaten into your time by 3 minutes. So and thank you for sharing the content of this in GitHub. I'll make this available soon after the meetup. And if you make any changes, the power of GitHub, everyone will get the updated version, which is great. Just a short reminder or a request, which I want to post in the chat. At the end of the meetup, I will be sending out a survey. It only has 3 questions. I wouldn't actually call it a survey. It's just an interesting way to find out who attended the meetup and where people attended from. And as I've done last time, I'm going to put the output on a map and see exactly where people have connected, because because we're doing this in a virtual environment, we no longer have to be physically in London to host this. So it was more of a curiosity to see how far we can actually go. I mean, Eric is in Seattle, and I think it's still the first half of the day. It's still morning for you, Eric. Okay, and next will be Anton, and he will be talking about a project he's been working on, Hawk, which is a data center modeling and simulation tool which can be used to figure out what may happen in case of planned or unplanned outage. Anton is a telecommunication industry enthusiast who started as a traditional network engineer, which is something I appreciate very much. And Anton mastered networking skills. He's dual CCIE, and then he's expanded the area of interest into data center and also into network automation and programmability. And he's the co-author of Network Programmability and Automation Fundamentals book. And without further ado, Anton, I'll make you the presenter. And the
Perfect. Thank you. Good morning, good day, good evening, wherever you guys are. Happy to see you all at this wonderful event, and thanks for having me here, folks, from the London Network Automation Meetup team. Let me share my screen and then we get rolling. Could you see my screen now?
Yeah.
Okay.
I can see it.
Perfect. So let's get started. So what is Hawk? Hawk is just like night, nice abbreviation of the highly efficient automated weapon kit. So the thing is, everything starts with a story, right? And my story was that at some point, I unexpectedly break the data center by the preparing, well, not very well preparing one of the changes. And technically, I was doing the software upgrade, and I was thinking, okay, so I pretty much know all the links in the data center. However, and I was thinking, okay, I could bring these devices down, and there will be no impact on the fabric. I could bring other devices down. Will be no impact on the fabric. I have enough capacity. I know this by heart, and I just go ahead and start preparing my, or actually preparing, executing my software upgrade. All was good, and then in a few minutes, I'm getting the call from some of our support team telling me, okay, guys, sorry, is something's bad? Well, not supposed to be bad. Okay, so start checking. Okay, I'm pretty sure I know that I was doing, and I start thinking, okay, oh, some of the link was supposed to be up or not. And think such a shame not to double check in advance. And then I started thinking, okay, if it would happen to me, it's pretty much would happen to any of my peers. I mean, the guys who I'm working with, pretty much, it's very easy to overlook that some links are really down for whatever reason. If you use any time, I mean, if you dealt with the big data centers, it's very easy to find some links are down. Obviously, it's not good, but it might be, and generally not that a drama if some links is down, unless you have enough redundancy. And this was the case. I was starting thinking, okay, how I could create something that could help me prepare way better, especially if we are planning for the maintenance activity in the environment where we have, say, 200-300 switches, and we have a lot of links, and I know that probably some of them might be up, some might be down. Obviously, we're not talking about the network monitoring, it's a completely separated topic. But when I'm planning some activities, try to figure out what would happen if I need to take this device out of the operation. Okay, how could I do? I like Python a lot, pretty much probably as Eric, and was dealing with this for already quite a while and thinking, okay, is it Python something that could help me with solve this problem? So my problem statement that I was trying to solve was there are actually two things. The first one, and that is very easy to rush, especially when you're preparing for the planning and not check everything. Like you might check all the interfaces, you might forget about the BGP, or you might do something else. Another one, it might be not really necessarily related to the configuration, because we might have a configuration snapshot using Badfish or anything else. Badfish tell me, oh, okay, if like this link is down, it's not generally a problem, I still see the route. However, it's not taking into account the real state of the network. And that's why I was thinking, okay, how I could take also into account the reality. So on the other hand, if you're taking too long preparation, checking all the things, it could be that by the time we're going to the effectively the change, the state of the network might change again. So it might be that there was another change has done, or just there was some activity, or just, I don't know, SFP has failed, anything could happen. So how I could quickly give a view of the real state of the network and do the analysis from the perspective of what I need. Say I need to bring some devices down or some links down. How would it affect the connectivity between my devices? So that was the ideas is, or like the requirements to the solution. Take a look on the real snapshot, make the what if analysis on the real snapshot, not only based on the configuration, but really taking into account what I'm having right now, and ultimately give a view to me what is going right now on the network. If needed, quickly create also the snapshot in the format simple to represent to the management to explain how does it look like, or if something has happened, why. The latter is important because all we know who works in the network operation, especially if something bad has happened. Okay, the question why it has happened, what exactly was the problem, how we could avoid this in the future, and so on and so forth. So this is a link to the to this repo in our GitHub, so I could download and play around with it. I will show you today some things about how this stuff is working. So with the idea in mind, what Eric was saying, quite a lot of resonate, because another problem that I was need to think about, need to work in the big environment with hundreds of the switches. So wherever it's possible, I was trying to think where I could use the Asyncio and all sort of the async libraries which are reliant for the async IO. So as an inventory, I'm using the netbox. Probably everyone is using, or at least aware about the netbox. So data center, infrastructure management, IP address management tool, quite cool thing. Open source allows you to store and document quite on a good level, again, how your network should look like, including your all sort of network equipment, switches, routers, even VMs, and a lot of other things. So, okay, but if I need like to collect the information from the networks, not only about their devices, but also about the interfaces, IP addresses, might be quite a chunk of the requests I need to do. It's taking time. It might take even a few minutes, like if you need to do a couple of hundreds or even more requests. So therefore, start thinking, okay, probably could do this in sync mode. So using IO HTTP, relying on sync IO to perform the call in the manner that Eric was explaining and collect the data. Second one, how I could then collect the data from the devices. REST API from the netbox obviously depends on how powerful the box when netbox is running, but generally is more or less okay. Switches generally less okay. They might be less responsive, they might be somewhere I don't know, located in the another side of the world. And then I have also the transmission latency, not only the processing latency. So how can I make sure that I am collecting information from the devices as quick as possible? At the time I was start building this tool, it was probably a few months ago. I was scanning what are the tools existing. I have seen there scrappily. I don't know, for whatever reason I decided against. Figure out that I think SSH is available for quite a bit. Have tested it, worked fine for me. So allows you to use, like if you have used with the Paramico, pretty much like Paramico, but asynchronous version. So go to all the devices, collect all the necessary information, collect it back to me, and then I could parse. Then again, what Python have in the library to do the analysis? So because at this stage, when the processing and collection, it's just about the collecting the info, what I need to build the mass model of the network. So quite a good libraries to have figured out, not synchronous, but in this case, as we are doing further activities locally, I don't have IO problems anymore. So probably I have CPU bound problems, but even in the very big data centers was not that big problem. I'll explain in a few minutes why. And the libraries that I was used was Network X. Again, I think one of the most popular libraries for their any sort of the network analysis or the data analysis allows you to create the proper mass graph containing the nodes, edges, metadata associated with both edges and nodes and the graph itself. And not only to build the graph, it's like a representation of a bunch of the classes, but also to do the certain analysis. So say it has one of the analysis that I'm using is SPF check. Basically, I could provide two endpoints and ask, do I have the connectivity between two edges or not? Probably could also add some further limitations like checking some other things. Pretty much, you could think about SPF that it was OSPF or ISTS is doing just the extra algorithm. And then I would also like to create a quick visualization. Not necessarily I need to do it for the analysis, but just like nice to have feature to explain someone what's going on and why I'm doing this step that I'm doing when I'm planning this or another task. And for the visualization, I have taken a library which is called pywiz. Basically, is a Pythonized version or Pythonic version of the Wiz.js library. The library is super simple. With 3 lines of code, allows you to create the responsive HTML page with JavaScript to represent the data, which is very easy to use with Network X effectively. The Network X could be imported and pywiz, and my data is like done. So again, as I said, I was building this for a particular case to help myself and my colleagues to properly plan their maintenance activity or planning of sort of the activity. So I already mentioned about the Asyncio, so all sort of the libraries, Asyncio, IO, HTTP, Async SSH, to use where I have IO related tasks, meaning connectivity with the netbox and pulling the info from the netbox, and connectivity from the devices. Allows to save a lot of the time. Just to give you an example, so I was comparing someone, just to reiterate what the Eric probably was saying, the tool, when I was originally just pulling the data from the netbox and was trying to draw, I was pulling from the netbox about, I think 8,000 elements, probably 10,000. So the whole data center with the servers and the network interfaces, switches, using the requests, the standard one, Asyncio was not Asyncio, the standard requests, like request response operation was about 30 minutes. With the Asyncio, same amount tasks, same amount of the elements, just about of 2 minutes. So obviously, so nothing comes for free, right? When I was comparing the CPU utilization graph, when I was using request, there was like nothing visible on the server side. When I was hammering their netbox host with a lot of thousands of requests per second, the CPU utilization of the host was like spiking almost to the top. So that's why we need also to think about when you're bringing this to really production environment, probably there is some balancing might be needed, unless you have obviously unlimited resources. I mean, like really hundreds of RAM and the CPU so that you could accommodate this data. So the second thing was looking into the mass, because mass is what our network's built on, right? As said, SPF, just Dijkstra algorithm, this is coming into the networking from the traditional mass. So when we're doing the analysis of the network, we're just coming back. We take the real data from the network, we create the mass representation, then we could do the necessary analysis, taking into account nodes, edges, and the attributes. Another problem that I was saying, and I will show you now, I think just the next slide or the demo, what was, yeah, so if I need to do the various combination time, if I like to bring one device is easy. I just take one device out of the graph and then just calculate whether I have connectivity between endpoints. But what if I need to do 2 or 3 or 4? That this is where I get into the standard O square and time problem, where if we don't do any optimization, they basically would be redoing the same activity. Say I need to, I would like to check if I would like to bring 4 nodes down, and I'll be checking first. If first node is down, what is happening? In second node is down, in third, in fourth. So we have the 4 iteration. Good. Then first and second, first and third, first and fourth, then we go into the second, we'll be again checking by default. If 2 and 1, if I mean creating the standard loop. So we're thinking how we could reduce this time. So we're adding the saving the of our existing combination that we have checked, just a sort of the extra memory frontier, just we are checking. If we have already checked, doesn't matter in which sequence this amount of the node, this particular nodes, we don't recheck this. Allowed us to bring down their like time to execute the script roughly by 50%. And the more nodes we are checking, the more visible would be this saving. And yeah, so another thing was quite an interesting learning curve for myself previously is recursive function. I know some people don't like that much, but at their like environment where I don't know how many nodes I would like to check, whether it is 1 or 2 or 10, I don't know really how to create, I mean, I don't have predefined limitation up front, how many like recursive checks I need to do. So that's why like recursive function from the Python is a great helper in this scenario, just to make sure I'm checking that many, how I would like to have, not knowing in advance when I just create the script. So this is a quick screen, but rather than have it shown it to you right now, I will show it to you in the demo, just for those who are not attending and would be watching just the slides. So let me get back to my CLI and enable this. So just the cloned repo from the GitHub. It's working for the example of the Python CLI, so it could be integrated with anything. I didn't have yet like the requirement, or I mean my personal requirement to integrate with nice front end. Probably will do it at a later stage. So pulling all the necessary variables from the environment. So this is my lab. I'll show you just in a second. So username, password, so storing in the environment pretty much what Netbox is doing itself when you need to store something like Napalm creates within the Netbox. And Netbox URL and token, so that we don't store anything in the files locally, just using it for the time being once our script is running. So I will show you, this is our lab on the inventory level. So we have 6 devices, their management IP addresses, and the platform type. So the first thing first, we would pull the data from the devices and see how they're looking like. Probably first, the tool has a quite, I think, detailed help. At least I was trying to make it detailed as much as possible. So we have possibilities through the arguments to the script provide which data center we are calling from. So basically, this would be what we are asking Netbox to tell us back. We could also save the local cache. So basically, if I'm doing the pulling and I need to pull like information from 200 switches, I don't need to do it all the time. If I'm preparing the chain, I could do it once, save on the cache, and then do all my analysis using the locally stored cache. So that's why there's 2 flags. And then all other parameters is entries to do the various checks. We also have possibility to build various topologies. So for now, I focused on the BGP, IPv4, IPv6 CVPN. However, I'm working to add LLDP and BFD again, given it's possible to collect this information. And then, as said further, is analysis. I'll show you how these stacks are working and again why it was created. Basically, the idea, we could specify how many nodes we could bring down, which node types I would like to bring down. So one of the important thing probably to show, okay, so before I go into this, which connectivity between node types I would like to test, or between particular nodes if I'm interested about the particular nodes. Pretty much same, also I'm testing whether certain nodes types or specific node names down. From the inventory perspective or from the data types perspective, I'm thinking that probably different companies have different their naming conventions, what they call, and pretty much it's about the data center, because I was starting about the data center. Leaf, spine, border routers, aggregate, different company has different names of having this. In order just to avoid hard coding, so this is configuration file, pretty simple YAML format. I was quite inspired by the Nornir, how they structure the configuration file. Was thinking, okay, probably I could steal the idea from the Nornir. And providing this, how inventory is looking like, how logging is looking like, where output is stored, so if I would like to have the logs, and also the mapping. Basically, this is internal classes inside their program: leaf, spine, border, aggregate, TCI. And this is the names that could be in the netbox. So technically, we could have any name in the netbox. I don't know, like whatever you could have. I don't know, public leaves, or I don't know, per product type, something like database leaf or something like this. Anything, it will be just internal to map to the particular class leaves. Same with the spines, borders, and the aggregate. Whatever you have the name, you're just providing what are this name. So this is mapped to what we have in the netbox. From the role perspective. Right, so quickly pulling the topology. How does it look like? So we provide the operation draw. Basically, we have operation draw and analyze at this stage. There is another one which is in demo, probably show that later. So once pulling the data, so as pulling for the Nornir data center, it's called NRN, so from Nornir lab, draw. If I'm jumping back, this basically, as you see, this size in the netbox called NRN and showing the data. For now, I was building again for a particular case for the cumulus, but the idea of that we are decoupling the data pooling and building the graph. So it's, well, easy enough to extend to any other vendor. Again, on the plans is to add the open config support so that we could pull the data using the netconf or GNMI, whatever, from the devices, and to then just parse, structure proper information to the graph to make sure it's working like. So believe the data now is pulled, and we have in the output folder created the new folder telling us the timestamp when we have made this polling and the topology. So let's take a look inside. And it is drawing. So what I have right now, so 6 devices. So by default, it's collecting their IPv6 topology. So showing me what are the device IS number, what is router ID, which plane they believe. Their leaves doesn't belong to any plane by itself. However, from the spines perspective, we see we have plane 1 or plane 2, which is basically showing visually what are our current states. So all the links are up. Now, running the basic analysis, the default analysis, we are checking the communication between, now you'll see, I'll show you probably the cache. Cache is stored just in the 2 JSON file. One is what we have pulled from the netbox, another one what we have collected from the devices. So running the basic analysis, now we use flag L, basically meaning local, so pulling the info from the local cache. Analysis relatively quick. So tell us if this node is down, we have connectivity check passed. If this node is down, connectivity check passed as well. As said, by default, we are using the connectivity between all leaves and all, so between all leaves and other leaves, leaves and border leaves and borders to each other. We could modify these rules. Also, what is generated for this analysis, so this is just directly in the CLI, we could have a quick view. Or we could take a look in the HTML page. So just to store it, if we would like to attach this as a part of the change management process, that was analysis. We have checked if this node is down, we are fine. We don't have any connectivity. Now, let's modify this rule slightly so that we would see the failed node. So we could provide a lot of details. I could say that I would like to have 2 nodes down of the spine type. Basically, 2, it means from 1 to 2. If I would put here 3, obviously I don't have 3 spine, but would be from 1 to 3. So all combinations of 1 node downs, all combinations from 2 node downs in this case. If 3, then to 3. So taking this data, building. So now it would say us, okay, if we have 1 node is down, connectivity check pass, no issues. If both of them are down, we are failing. And if like another one is down, no issues. So what exactly failed? We are not shown here in the quick view, but we know, okay, probably there is an alarm. So going into the Finder, looking into the file, and it shows us, in this case, if these hosts are down, those connections are broken. So we see leaf 1, so leaf 11 to leaf 12, leaf 11 to border 1, leaf 11 to border 2, and so on. Basically, it shows all these links would be affected. So, okay, and then you could define, generally, connectivity is broken. We probably know that nothing is connected to leaf 1, so it's not that important for us. However, we would have this view. So now, this is what is happening in the properly working network. Let's say, okay, so probably I need to show you some more things before going to the demo of the bringing down. I could specify that I'm interested only in connectivity between the leaves. So I don't really care about whether traffic going out of the data center. I'm analyzing the connectivity for, let's say, my layer 2 traffic between the servers. Same stuff, we're just telling further info that we are analyzing connectivity only between the leaves. Looking into that. And then analysis done only from the leaf perspective. So we're excluding the borders from this operation. Now, we could also check the particular node bringing down and how to affect connectivity between other nodes. So we're in this case, I'm interested in just bringing this and nothing else. So, okay, we'll do this check. In this case, I added the flag S again to repull the data. So connectivity pass, if this node is down, connectivity between the leaf and border continues working. Now, let's quickly bring one of the sessions down. So I'm going to the switch and just shoot down this GP session. So all the GP sessions are up. Now I would flap one of them down. So checking again our summary. So we see the GP is done. Probably cable isn't plugged, probably something else. Now, if you collect our information again from the devices, using SO, we are repulling this data, and take a look on the new visualization. You would see now one link is done and we see the state is active. So the info is pulled from the spine's perspective. So, okay, this link still on the representation is there, but is red, like signaling us, hey, we have a problem. And what is though means for our analysis? So analysis would be treating like this link as non-existent. So therefore, if we would run the analysis we was doing again, so I have already pulled this data, so let me end the L. We see that now, also, even if spine 2 is down, we have issues. And we could take a look again in the detailed view that if these two nodes are down, we could expect that in the normal state of our network, this connectivity will be broken as well. However, if this node, if only this one node is down, connectivity will be broken either. I could check that probably this is not affecting some other connectivity types. But let's say if I would like to check the connectivity, not between the leaves, but between the border. So in this case, if the spine 2 is down, it's not affecting this line. So, and this basically what is about the hawk. I mean, there are a lot of Python code behind. I think I don't have the time to go through to explain. Just probably would like to quickly say, if you're interested to learn a lot more about the hawk and other things, you could learn a lot from my blog, karneliuk.com, or from the training that we are running about the multi-vendor network automation, which we are starting in September. And it's basically completing my presentation. I hope you're still awake, not falling asleep. And thank you very much. If you have any questions, happy to answer them.
Yeah, thanks, Anton, and that was very useful. Yeah, if anyone has any questions for Anton or for Eric, please feel free to ask them now. Either post them in the chat or unmute yourself. You should be able to unmute yourself. I think Katalin has a question. Oh, there's a lock. Let's see. Should be able to unmute. Yeah, there you go. Katalin, you should be able to ask a question now. We can't hear.
I think the voice from the Catalan is now gone. I mean, the symbol doesn't show that he has connectivity for the voice.
Yeah, let's see, because there are some new options. So I'll see if I can remove the lock for everyone. I can see everyone has a lock, so I don't think it will be. Okay, Catalin, let's try again. Can you hear me?
Yeah, in the meantime, sorry, go ahead.
No, I have unmuted Catalin. No, not yet.
Something looks like something with the voice.
Yeah, try to post it in the chat. Sorry, Eric, you wanted to say something.
No, I was just going to go back to the question that we had before. So the question was, let me read it. It says, how to integrate Asyncio with linear dash script. And I think, you know, maybe I'll go first and then Anton could go. I think perhaps what they're saying is that, so because linear graph is supposed to already hide that from you, you have to do just, just give it a bunch of items and go deep. So you don't have to worry about async IO. But if you're thinking about optimizing other parts of your program besides just grab the output, that other parts that are IO bound, right? So that's really the two. One is you want to make sure your task was bound. Then that will async IO could potentially help you. And then the second is you really find a library that is awaitable. So if you look at the examples that Anton gave, it was request, and it was compared between request and AIO HTTP, right? So AIO HTTP allows you to make API calls, and then it will release, it defines a dunder await object that tells you that once go and do something else and come back to me when it's available. But request doesn't have that. It was done before async IO was available. So so that is, you want to find a waitable tab or that does that, then you actually integrate async IO together. Besides just using the non-linear extrapolate, which already abstract away from it, just like Hop does.
I think probably just to add on top, yeah, to what Eric said. So the Asyncio has one, big advantage and one big disadvantage. The biggest advantage, obviously, from the Asyncio, the speed. Non-linear would give you the speed, wouldn't give you speed that non-linear that Asyncio could give. The biggest disadvantage is, though, the library needs to support Asyncio A, B. You need to know how to rewrite the code. It's not all the time easy. The first time when I was trying to write the code for the IOHTTP, I think I spent like 3 or 4 days trying just to make it work in somehow, because you need to think and see a little bit more deeper, so that the thing goes with requests. So if you would see on their source port, it will be all the time different for each and every request. So it is like opening and closing TCP session, which is not the case for the Asyncio. Keep the TCP socket open for all the time. And like once you start understanding this more in the details, or at least start looking this, you can start understanding where the basically performance is going on. Besides what Eric's mentioned, that obviously library should support this mode, that you make the request and leave it somewhere, going to the next one, it just will wait for the response to come back. So ultimately, if you could find a way how to deal with this in IO, obviously it's the right way to go. However, think if their effort is worse. If you need like to pull information about 10 devices, you need to manage 10 devices, probably Netmico is easier. If you need to manage 100 devices, well, that is a different question then.
Yeah, thanks for that. And I think that was one of the questions that was asked at the beginning of the session. Are there any questions that anyone wants to ask? Either post them in the chat or try to unmute. I'm still trying to figure out what this lock means on the mute button. If not, I think there was also a question which was posted in the chat, but I saw that some people already replied via the Meetup platform. What are the current weapons of choice for parsing switch configuration? George continues to say, I've had good luck with text FSM, and Network to Code has a large repo of text FSM templates. Anything else you've used and would suggest?
I think
I'll go first, and then
go. Sorry. Okay, so I think the thing is really how much you need to parse and how deep there. if for the vendor A, TextFSM is created and the entity indeed has a great job for creating the library, is a nice way to go. If you need to create your own TextFSM, or for those one who was creating TextFSM, you might know that sometimes it's quite painful, especially when you try to deal with the output, which is not all the time predictable. There is an example, Juniper device, and you like to pull the data about the session up or down. And basically, it might have extra space internally or not. And this is several effects creating the TextFSM. Sometimes TextFSM, the way how you create, would be missing the space or would be having another way around. So the TextFSM is great, but you also need to understand that might be some caveats and all the time testing that. On the other hand, there is not that many, like, let's say, alternative regex, one-off, but obviously require then to quite in-depth understand how the regex structure is working. I tend to use, again, if there is a simpler request regular expression to myself, but obviously if big output needs to be done in multi-line, TextFSM here, I think, is a champion.
Yeah, thanks for that. And Eric, you wanted to answer that as well?
Yeah. So what I just want to add like I think I assume you're just talking about CLI, right? Like you have to go string scrape. Otherwise, go with API. Like that's a short answer, but if you do have to string scrape a bit Python. So they represent themselves as being like a test framework, but really there's a long chunk of parsers and but that's in Cisco specific. So if you're dealing with Cisco ties and you want to have a parser, just give PyATS a shot.
I have probably one more question. So Katalin texted me, so he tried to post it into the chat, but for whatever reason it didn't come. So hi, one question I have on Hawk, one interesting question in networking modeling is around link utilization and capacity. Do you plan to support that? Is there any need for that type of answer in the DC space? Thanks for the tool. Always nice to see efforts on this space. So yeah, thanks for the question, Katalin. At the present moment, it's not something I was implementing. I'm thinking about this and have some already idea in the demo, just probably because from the current perspective was not again the problem for me. However, the question is absolutely correct because in certain cases, if the link is already like utilized, let's say more than 50%, that definitely something needs to be into account. So I do definitely have a plans. I do not have yet ETA when these plans will be implemented, but thanks for the question, mate.
Perfect, thank you. And so there is another question on Ansible, which Anthony sent when he signed up. We use Ansible for our network automation. Do you have any advice how to best set up our playbooks and variables to facilitate CI/CD pipeline automation? We're currently creating a separate project within a single playbook and using Git submodule to bring our host group variables, which works, but it's far from ideal. I know the presentations weren't around Ansible, but if someone wants to pick this up. If not, I can probably just save it for.
Yeah, no, I was gonna say I don't really have any like besides. I think the problem with Ansible is there's always that 5 different ways, and so you could like variables directly within the book, or you could have it, but now I think 2.0 is where they start to standardize like variable locations and so on. So I don't have one usually save the variable to each of the host files, and like yeah, I haven't supported in a while, but that's what it is, right? Host files and just how host variables, on blue and so forth. But I do. If it's a secret, it's environmental variable. So they tend to be on the simple side, but that's that's how I do it.
I think just to add on that, probably also the AWX could be quite a good helper if like you have possibility to use AWX for the helpers, because we have store that as a part again as our project or providing at the stage when you are like running your playbook with either by a survey or rather the variable that you applied at the part of the task, which is again I think could be, I mean, by help of solving this task.
Perfect. Thanks for that. Let's have a look. I can see there is something in the chat. Okay. Eric has posted something.
And that was a
Anthony,
link to the AWS secrets.
perfect.
Yeah, so we don't use that for Ansible per se, but everything related to our AWS deployment and requires like API keys, and it's encrypted on REST and so on. So we use AWS Secrets Manager. There's an equivalent for every cloud providers and OCI. But for us, the only specific to AWS, like we just use that.
Understood. Thank you, Eric. I think if there will be any more questions, I think we can probably take one more question, but I think you can also post some questions in the meetup for this event, because this way everyone will see it. So Eric and Anton will be able to reply, but I saw that other people will probably have some good insights and probably be able to answer some of these questions. Just checking the chat, no more questions so far. I just want to say, because we're coming towards the end of the event now, I just want to say thank you to Eric, thank you to Anton for sharing the presentations with us, and for contributing to this nice little community that we have, and to the network automation space. I also want to say thank you to Martin Hansen from Cisco for helping us have access to WebEx. I know there are some new features which I'll probably need to get more familiar with. And also at the end of the meetup, I'm gonna resend the link to this survey. It's basically 3 questions, more on the lines of whether this was the first meetup that you've attended, and also where you're actually where you have actually connected to this meetup from, and then I'll put the information into a nice world map, so we know exactly who attended and where from. And I think there is one more question that Dario has posted. In what use cases, Eric, would you suggest to use Pydantic versus build a module to document and enforce data past the functions methods? Do you want to pick this up as the last question?
Yeah, I just use Pydantic. What if Pydantic doesn't support? Then build. Yeah, let's go put it code first. That's always what I do. I find what's available out there, and if it's me, then I'll do it. But from what I saw, Pydantic actually is pretty awesome in covering a lot of use cases. For example, when you're a variable globally, you actually Pydantic to say it should be a non W or not. Well, at least as far as I cover use case, not even like a single use case where I need to build my own to but also the so then your me so this API actually reads those and then enforces it for me. So I think it's just depending on use, but gosh, the pretty job for uses, and you're more to force those restrictions.
Thanks. I think there were some issues with the quality of sound that came towards us, but yeah, I think most of it was probably well understood. Okay, so I think we're gonna wrap it up here. Again, thank you, Eric, and thank you, Anton, for joining. Also, as a reminder, if you want to present, I know some of the people who have attended today have also presented to previous meetups. But if you have a new project or if you have something that you want to present at the next meetup, please feel free to reach out to me. Feel free to reach out to us. There is the email on the screen. Use Meetup, use LinkedIn, whichever ways of communication you prefer, and we'll line up something for the next meetup. And until then, I hope you stay safe, and thank you everyone for joining.
Thanks a lot for a wonderful event, guys. Thank you. Take care. Thank you.
Thank you. Have a good evening.